So here's the last question that we have to do. Solve for exact values of theta in the interval where theta is between 0 and 2 pi. So there's a couple of different things that I notice about the way that this question is written that I want to point out to you first before we start. So number one, solve for exact values. Whenever they say exact values, that means that they need magic table values. So instead of decimals, you need to be writing radical 3 over 2, radical 2 over 2, radical 3 over 3, that kind of stuff. So just as a quick review, really quick, let's make another magic table. You probably should have one out in front of you right now, but what I want you to do is put it down, put it away. You can even pause this video right now if you want to make sure that you know how to do it by yourself before the final or the Regents exam that's next week, okay? So I'm going to do this really quick. It goes 1, 2, 3, 3, 2, 1. Everything is divided by 3's, or I'm sorry, everything's divided by 2's, and you get radicals on top of the 2's and 3's. Now tangent is the one that it's a little bit trickier to memorize, but what I do is radical 3 over 3, which kind of looks like it should be a 1, but it's not because the numerator is a radical 3. Okay? So we're going to have to use this magic table at some point during this question, so it's just a good thing to have. The second thing that I noticed about this question is it's saying theta is greater than or equal to 0, less than or equal to 2 pi, meaning that if one of our answers turns out to be 0, we have to write 0 and 2 pi, okay? Because both of those are within our interval. The last thing that I noticed is that it goes between 0 and 2 pi, not 360 degrees, meaning that our final answers all need to be in terms of radians, which is fantastic. That means that all the way at the bottom we have to convert them to radians as well. So let's take a look at this question and see what we're going to have to do. Sine of 1/2 theta is equal to the sine of theta. Whenever you see this 1/2 theta, that is one of the identities that's on your reference sheet. So let's go down here. It's not the double angles, it's the half angles right here. So sine of 1/2 a is equal to the positive or negative value 1 minus cosine blah blah blah, all that stuff. Which is fantastic, because you know what, we have to do it because we can't leave a double angle and we can't leave a half angle in our equation. But the bummer about this is we're going to end up with two different values, two variables, cosine and sine. So let's just see how this question works and we'll see what happens when we get there. So I'm sorry, I'm looking at the wrong one. This is sine. Okay, so sine of 1/2 theta is equal to the positive or negative value of 1 minus cosine theta divided by 2, and that's equal to sine theta. Okay? So what we're going to do is, because we have this huge radical right here, I'm going to go ahead and square the left hand side because everything's underneath the radical, and square the right hand side as well. So this becomes 1 minus cosine theta divided by 2 is equal to, is equal to sine squared theta. Okay. Let's just see what happens. We have a fraction over here, so I'm thinking if I write this as a fraction sine squared theta over 1, then I can cross multiply. So I'm going to have 2 sine squared theta is equal to 1 minus cosine theta. Okay. Alright, so let's see. If I add cosine to both sides and I bring this over, just so that I can set it equal to 0. Let's see what happens. I'm going to have 2 sine squared theta, just to get it just a little bit more organized before I think about what I have to do, plus cosine theta. And then I'm also going to have to subtract that 1 and bring it over to the other side. So that's minus 1 is equal to 0. Okay. We kind of ran into this problem a couple of problems ago when we had 2 different variables. This time we have a sine squared and we have a cosine theta. Now, at first I was thinking maybe somehow if this turned into sine squared theta plus cosine squared theta, then everything would turn into a 1. But that's not the case. So don't, try to rearrange the equation somehow to try to make that work, because it's not going to work. But what I do know is, going back to all those equations that we wrote before right here, I do know that this equation has a sine squared theta right here. And I have a sine squared theta in my problem right here. So maybe I can rearrange this equation up top somehow and get sine squared by itself. Let's see. If I get rid of the rest of the stuff that we were working on, and I do minus cosine squared theta on both sides, then I know that sine squared theta is equal to 1 minus cosine squared theta. Awesome. That's going to work. So right here, sine squared theta, and this actually, John, is exactly why I always want you to write things in parentheses, is because that 2 out front is really tricky. So 2 times. Now, instead of writing sine squared theta, I'm going to write 1 minus cosine squared theta. And why did I do that? Because now I have an equation that has all the same variable in it. Instead of sine, I have a cosine squared, which is awesome. It's exactly what I wanted. So then I'm just going to do a little bit of work. I have to distribute that 2 on the other side, and then I have to rearrange some things. So this is 2 minus 2 cosine squared theta. Whoops. Plus cosine theta minus 1 is equal to 0. Okay. I need to rearrange it just a little bit more, and I have 2 common or similar terms right there and right there. So this is negative 2 cosine squared theta plus cosine theta, and then I have a positive 2 minus 1, that gives me a positive 1. That whole thing is equal to 0. Now, obviously, because I have a 2 out front, I'm going to have to do circles and squares, but before I do that, I never want to do circles and squares with a negative out front, so I'm going to have to go through and change, multiply by everything through by negative 1, or just go through and switch all the signs. So this becomes a positive 2 cosine squared theta minus cosine theta minus 1 is equal to 0. So let's see what that's going to look like. Let's do circles and squares. Okay. Positive 2, so 2 and a 1, and then a negative 1 times 1. So 2 times negative 1 gives me a negative 2. 1 times 1 gives me a positive 1. Negative 2 plus 1 gives me a negative 1, which is exactly what I wanted because that's what I have right here. Awesome. So let's go through and write these as our factors. This is in terms of cosine, not x. So this is 2 cosine plus 1 times cosine theta minus 1. And that's equal to 0. And that's going to give us a couple of different answers, which is awesome. This eventually ends up to be my favorite part because then you get to figure out what the answers are. So let's see. 2 cosine theta is equal to -1. So cosine theta is equal to -1/2. And then cosine theta is equal to a +1 as well. Great. So we're going to have a couple of different answers for theta. And the first one, I'm going to take a look over here, and I'm going to say cosine theta is a -1/2, so therefore, all students take calculus, where is cosine going to be negative? Cosine is positive in the first and fourth quadrants, therefore it's negative in the second and the third. It's never really fun when we have a negative answer because we're always going to have to figure out what our reference angle is because we need 180 minus theta and 180 plus theta. So in order to figure out what theta is or what our reference angle is, we have to think about what it would be in the first quadrant. Our reference angle is equal to a positive value. So this is on our magic table, which is right here. So cosine theta is equal to 1/2. That's at 60 degrees. So this is 60 degrees. But that's not one of our answers, it's just the reference angle. So theta is equal to 180 minus 60, which is 120. And then 180 plus 60, which is 240. Then my last answer comes from right here, and because that's a +1, I'm going to take a look at my unit circle, and that's not a unit circle, is it? Nope. My unit circle. And cosine is the x value, so you could go along and make all those points, figure out where the x value is going to be a +1, and this is the only place where the x value is a +1, which is 0 and 360 degrees. And because when we look all the way up here at the top of our question, it was theta is greater than or equal to 0 and greater than or equal to 2 pi, that means that we could include both of those in our answers. So you need 0 and you need 360. Now, this is exactly why I say go back and reread the question at the end, because going up to the top was able to remind us that, alright, we don't want theta in degrees, we want theta in terms of radians. So I'm going to have to convert every single one of these. So, in order to convert degrees to radians, you multiply by pi over 180. Now you're going to keep the pi symbol in your answer, and all you're going to do is use your calculator to simplify this fraction. So 120 divided by 180. That should give me, like, I think it's either 1/3 or 1/6. Oh, 2/3. I was completely wrong. So this is 2 pi over 3 for the first answer. I'm going to keep my pi symbol and say 240 divided by 180. Enter, math, enter, enter. This is 4 pi over 3. 0 is always still just 0, and we know that 360 is 2 pi. So those are our 4 final answers for this question. And I'll be right back.